This is a float and thermostatic, or F&T trap. It's generally classified as a mechanical trap because one of its major internal parts is a ball-type float mechanism for removing condensate. However, it also has a thermostatic bellows that reacts to changes in temperature and is used to remove air and non-condensable gases. So in this respect, the trap is thermostatic. More information about thermostatic traps is given in the part of this topic that's entitled Thermostatic Traps. For now, let's look at how a typical F&T trap works. As condensate enters the trap, the accumulating condensate lifts the ball-type float that's attached to the trap's main valve. This action opens the main valve and allows the condensate to flow through the trap outlet. When steam enters the trap and reaches the bellows expands and the vent valve closes. At the same time, with the main valve open, condensate continues to flow through the trap and be discharged. The changing level of the condensate causes the float to rise and fall, which in turn affects how wide the trap valve opens and how much condensate is discharged. The buildup of air and gases in the trap lowers the temperature and eventually causes the bellows to contract, which opens the vent valve. Then, the air and gases are discharged through the trap outlet. The reaction of the bellows to temperature changes enables air and non-condensable gases to leave the trap and keeps the trap from becoming airbound. Air binding, or becoming airbound, is the condition that results when air fills a trap, closing the trap valve and keeping the trap from operating. If operating conditions cause condensate to build up to the point that the trap becomes waterlogged, the relatively cool condensate causes the bellows to contract, which opens the vent valve. Then the condensate drains through the open vent to the trap's discharge line. Dirt accumulated below the trap valve can cause an F&T trap to fail because large dirt particles can restrict the movement of the float mechanism. Failures caused by accumulated dirt particles can usually be avoided by installing a strainer at the trap inlet. Also, F&T traps can fail if water hammer or high pressures cause the trap's float to collapse. Other common problems that may be associated with F&T traps include disconnection of the float from the trap valve and damage from freezing if condensate isn't drained from the shutdown trap. In this part, we'll look at the operation of thermostatic steam traps. A thermostatic trap operates in response to the differences in temperature between steam, condensate, and air. One of the most common types of thermostatic traps is a bellows trap, which gets its name from the thermostatic bellows that is the trap's main internal component. At startup, the bellows is fully contracted and the trap valve is wide open. Condensate and air are pushed ahead of the steam directly through the trap outlet. Once steam enters, the temperature in the trap increases and the bellows quickly expands. As the bellows expands, the trap valve closes and steam is prevented from escaping. But as more condensate enters the trap and contacts the bellows, the relatively cool condensate causes the bellows to contract. As the bellows contracts, the valve opens and condensate leaves through the trap's outlet. Air and other non-condensable gases are usually cooler than steam, so they also cause the bellows to contract, which opens the valve and allows the gases to escape along with the condensate. A disadvantage of a bellows trap is that it generally can't be used in situations where pressures are very high because the bellows might collapse. Another disadvantage is that water hammer can rupture the bellows and cause the trap to fail. At any given temperature, the two different metals in the element expand and contract at different rates from each other. This causes the element to bend back and forth as temperature changes occur. Cool condensate, or air, bends the bimetal element one way to open the valve, and steam bends the element the other way to close the valve. Since the valve of a bimetallic trap is fully open when the trap is cold, This type of trap is effective during equipment startup because the trap can quickly eliminate air and cold condensate. But the trap response is more sluggish when steam has reached normal operating temperatures because time is required for the dissipation and absorption of heat that opens and closes the trap valve. Most thermostatic traps discharge condensate intermittently. The time it takes for condensate to discharge depends on the amount of condensate in the trap's drip line. The more condensate there is, the less time it takes to cause the trap to discharge. Thermostatic traps are also excellent at removing air.